So in this video, we're going to graph the parent functions for 4 different functions, including the constant function, the linear function, the absolute value function, and the quadratic function. So for each parent function, we're going to identify the equation, a table of values. We're then going to use that table of values to graph, and we will then identify our domain and our range. So to start, let's take a look at the constant function. The constant function, if we write down the equation, is f of x is equal to 1. And remember, f of x is just fancy function notation, so this really means y is equal to 1. And this is the simplest constant function that exists. Now from here, we're going to create a table of values using that equation. And what I know about this table of values, given the equation of y equals 1 or f of x equals 1, is that all of the y values are equal to 1. So no matter how many y values I pick, whether it's 1, 2, 3, 4, or 5, all of those y values are equal to 1. Now if I look closely here, there's no x in this equation. And because there's no x in this equation, I can choose x to be whatever I would like it to be. So I could pick 4, I could pick -3, I could pick 0, 2, and 1. It doesn't matter. X can be anything of your choosing. I just suggest picking points that are on your graph. So now if I go and plot these points, I go to x is 4, y is 1. X is -3, y is 1. X is 0, y is 1. X is 2, y is 1, and x is 1, y is 1. What I notice is that these form a horizontal line. So all constant functions are going to form a horizontal line at the given y value. In this case, the most basic one is y equals 1. Now, the final thing we have to do here is we need to identify our domain and our range. Remember that your domain represents all of the possible x values for your function. So we're looking left and right on the x-axis. And if I look at the graph, what I notice is this graph is going forever to the right and forever to the left, which means it's hitting every single x value that exists on the coordinate plane. Because we're using every single x value, we're going to write our domain as all real numbers, because it can use all possible x values to make that function. Now our y's, remember, our y's is our range. So our range is all of the possible y values that we need to make points on this graph. Because this graph is not going up or down, it's going straight horizontal, we are only using one y value here. We're using the y value of 1. So our range is simply going to be y is equal to 1. We can also see these domain and ranges from the table. Here we can see x is anything, which is why x is all real numbers, and we can see the only y value or range value that we use is 1. The second parent graph we're going to take a look at is the linear function. And the linear function is represented by the equation f of x is equal to x. So now from here, if we want to translate this into less fancy wording, we can just put y is equal to x. So we're going to create a graph of y is equal to x. So to start off, we're going to select x values. We have x is -2, -1, 0, 1, and 2. And because for this particular function, we actually have an x value, what we need to do is we need to take each x value, substitute it in, and find what y is equal to with that particular x value. So if we start with x is -2, if we plug x is -2 in there, we get y is equal to -2. So when x is -2, we're discovering that y is also -2. And then if we move on and we test out when x is equal to -1, so we're going to plug that in here, we have y is equal to -1. We then plug in 0, so we're testing out when x is equal to 0, what is y? Well, we have y is equal to 0. And then we start with the next one, so we do an x is equal to 1, so we have y equals, we put 1 in for x, 1. And then the last one, we have x is equal to 2, so we have y is equal to, and we plug 2 in, 2. So now we can go through and we can actually plot this graph. So we have x is -2, y is -2, x is -1, y is -1, x is 0, y is 0, x is 1, y is 1, and x is 2, y is 2. So we can see that this is forming a diagonal line, And if we connect those dots and draw the points all the way through, fully extend that line, we can see that we have a diagonal line where every single pair has x and y matching. So when x is a number, y is that same number. So that's our linear parent function. Now our last step here is to identify the domain and the range. So here remember that domain is talking about all of the x values. And if I look at this graph very carefully, I notice that the graph is going forever to the left and forever to the right, which means that our domain for this graph is all real numbers. And if I look at my range, which represents my y values, I notice that it's going forever up and forever down. So I need every single y value to create points on that graph. So my range is all real numbers as well. So moving on to the absolute value function, our equation for the absolute value function is f of x is equal to the absolute value of x. And hopefully in your brains you're thinking through what that absolute value function actually means. So from here we can change this into less fancy verbiage, which is y is equal to the absolute value of x. And hopefully you're remembering that absolute value works that by putting any number in to the absolute value, it finds that number's distance from 0 and changes the number to always being positive. So absolute value will always produce a positive number. So in order to calculate some points to graph this, I'm going to pick some x values between -2 and 2, and I'm going to substitute those values in for x and calculate the corresponding y value. So let's start with x is equal to -2. So we take x is equal to -2, we plug it in, we get y is equal to the absolute value of -2. Remember that absolute value finds distance from 0 and turns everything positive. So the distance from 0 for -2, turning that into a positive, is just 2. Then from here we can do x is equal to -1. So again, we go y is equal to the absolute value of -1, and again, absolute value finds distance from 0. So this is going to be equal to 1 unit from 0. It turns it positive. Now when x is 0, we do y is equal to the absolute value of 0. Well, 0's distance from 0 is 0. Then we have x is equal to 1. So we do y is equal to the absolute value of 1. Well, 1's distance from 0 is 1 unit, so that remains positive. And then we do when x is equal to 2. So we have y is equal to the absolute value of 2, which is 2 units from 0. So now if we go and plot these, we have -2, 2, -1, 1, 0, 0, 1, 1, and 2, 2. So because of that absolute value function turning everything to be positive, we can see that we have a V-shaped graph. Now from here, our last step is to determine domain and range. Remember, domain is focusing on all of the x values needed to make a graph. And what I notice here is that this graph goes forever from left to right. So our domain for this particular graph is all real numbers because we're using every x value as this graph goes forever to the left and forever to the right. And then our range values here, the y values that we need to make this graph, what I notice is I don't need any of these y values down here to make this graph. If I didn't have the whole bottom portion, I wouldn't need it. It would be okay. I could still see my entire graph. So all of the y values that I need to make this particular graph start at 0 and go up from 0. So our range is going to be represented by an inequality, and we're going to say we need all of the y values that are greater than or equal to 0. And last but not least, we're going to take a look at the quadratic graph. So the parent function for the quadratic graph is f of x is equal to x squared. And again, we can turn this into a less fancy version by writing y is equal to x squared. So we have our function there of y equals x squared. And then from here, we create a table of values. So we have x values from -2 all the way up to 2. So we're going to calculate those values. So we have when x is equal to -2. So we have y is equal to negative 2 squared. Well, negative 2 squared is negative 2 times itself, so negative 2 times negative 2 is 4. Then we have x is equal to negative 1, so I have y is equal to negative 1 squared. Well, negative 1 times negative 1 is 1. I then move on to x is equal to 0. So we have y is equal to 0 squared. Well, 0 squared is just 0. Then move on to x is 1. So y is equal to 1 squared, which is 1. And then we move on to x is equal to 2. So we have y is equal to 2 squared. Well, 2 squared is equal to 4. So if I pair those up in my table, I have 4, 1, 0, 1, 4. So then from here, I go over and I plot those points. So x is negative 2, y is 4, x is negative 1, y is 1, 0, 0, 1, 1, and 2, 4. So from here, I can draw my graph. And I can see that I have that general U-shaped graph. So the last thing I need to do here for my quadratic function is identify the domain and the range. So if I look closely here for domain, I'm looking at all of my x values. Remember that for domain, I'm looking at all of the x values I need to make points on my graph. And I notice for this one that it goes forever to the left and forever to the right, which means I need every x value, so my domain is all real numbers. And my range, we actually start with y values at 0 and go up. Notice I don't need any of these y values down here beneath the x-axis. So all of the y values that are above 0 and equal to 0 will help me to create points on my graph. So I can represent my range by saying y is greater than or equal to 0. So at this point, you should have a solid understanding of all of the 4 basic parent graphs, and you should be able to graph them at any time and identify their domain and their range.